Welcome to Deep Web, Web Cmdlets Deep Dive. So the agenda for today is I'm going to talk about a bunch of stuff that's up there on the slide. We'll get to it and you'll see what we're doing. First, we'll talk a little bit about me first. I'm a senior systems engineer at LinkedIn. I'm the author of Get PowerShell blog. I'm a PowerShell Core project collaborator. I do a lot of work on the Web Cmdlets. You might have known that. PowerShell Live coordinator, so all the stuff that we're now doing for the Twitch live stream stuff, the automation for that is something that I'm running. And you can find me as Mark E. Kraus pretty much everywhere, and it is Kraus that rhymes with house, and it's not Marka, it's Mark E. Kraus. But yeah, everywhere, Twitter, LinkedIn, perhaps, and pretty much everywhere except Facebook. So why have you chosen to come here and spend an hour and 45 minutes hearing about the Web Cmdlets? Well, IT has changed, right? REST definitely rules the world. So much of what we're doing is about web calls. It's no longer like point and click inside of some kind of interface that you have on the system. It's no longer about even just local automation, man. We have to work against all kinds of different APIs. We're working with things like ServiceNow, Jira, all these things have REST. The clouds that we're now, everybody's trying to get all cloudy, that all runs on REST. Paths and serverless, those all run on REST. And even your thermostat now runs on REST, right? So like everything is running on REST, and that makes the Web Cmdlets a very valuable tool to have in your toolbox. And spending some time studying your tools and understanding how they work can give you a more informed opinion about how to do your work and kind of master that. So I'm going to start off by just talking a little bit about how we do testing for the Web Cmdlets in the project. The reason for that is I'm going to be using that same framework to kind of do some of the demos in here. But we use a thing that we created called Web Listener. It is a ASP.NET Core Kestrel server. It's something that we run in CI to actually test the Web Cmdlets against. It's cross-platform then because it is on .NET Core. We run about 200 plus pester tests against the Web Cmdlets. So yes, we do actually do pester testing against our Web Cmdlets. We're not doing some kind of like C# based unit testing. And I'm going to be using it in this demo. So we're going to attempt the demo gods here real quick. So I've got a little script here to kind of start the web listener. And all it's doing is it's going to build the web listener and start it up. And this is exactly what we do before we run all of our pester tests in CI. So every time we build, every time there's a PR that goes out, every time that PowerShell is built, this gets run and all the tests that run against it. And of course, it's going to fail because we're good. So it boots up. There's a certificate that gets created so that we could do HTTPS tests. And then it runs on a couple of ports. So we have an HTTP port 8083, HTTPS port 8084. We're doing TLS 1.1 and TLS 1.2 tests. And it gives us a job that we can then control. But the gist of this then, if I do this here, do get web listener URL. Right, I get this right here. I'm just going to control-click that, launch it. So this is what we kind of get. Is a it's kind of a little web page, but there's also some little APIs on it. So like there's a get API, which kind of gives you back some JSON data and all that kind of stuff. So we pass in stuff, we get it back, and we test with that. But I'm only showing you because I'm going to be using it in the demos here. And if you're interested in that, all that is in the open source PowerShell project. Hopefully this, all right, that's good. So let's start off with some differences between 5.1 and 6.0 in the Web Cmdlets. So first of all, I'm only going to be covering invoke WebRequests and invoke REST method here. I'm not going to go into convert to JSON and convert from JSON, even though those are technically part of the web commandlets, and they're kind of intertwined. But some of the first differences you'll notice is that there's no more Internet Explorer integration. So this is both a blessing and a curse. One of the pain points of invoke WebRequest on 5.1 or earlier is that if you tried to run it in kind of a headless mode on a server as some kind of like service account user, it would kind of blow up unless you used like use basic parsing. And that's because by default, invoke WebRequest goes out and invokes an API back to Internet Explorer to kind of render that page and get back the DOM so that you can get that parsed HTML piece of it. And that means that now we don't have that parsed HTML. So in 6.0, that is now empty. It doesn't even exist on the object that you get back. So we're not doing the full HTML parsing. We only do the basic HTML parsing so you can get some links, find the images in it, and stuff like that we were kind of doing beforehand also. But you won't be able to get that full rich DOM that you were used to in 5.1 because that was actually Internet Explorer doing the lifting. And obviously, we don't have Internet Explorer on Raspberry Pi or Mac. So that's not there. We can't use it. Also, commandlets in 6.0 will only support HTTP and HTTPS. I don't know if you knew this, but in 5.1 and older, you could pass in a file URL or an FTP URL and actually use that. We switched to the HTTP client. It only supports HTTP and HTTPS protocols, so you can't actually use the FTP or file anymore. Also, no more SSL 3.0 support, so if you've got that still out there, shame on you, but it is no longer supported, and that's more of a .NET Core thing and not a PowerShell thing. We just have to live with it because that's what .NET Core decided. So I want to show you the basic parsing, kind of show you how that's different these days. And I'll make all of these available at the end of my presentation on my GitHub. So let's go through this demo block here and kind of explain what's going on. So I'm just going to go to this endpoint URI that's on this web listener that I've got that's basically just going to get the HTML page that I showed earlier. And we're just going to show how that differs. So a lot of these demos I'm going to be doing, I'm doing it the same way. There's a demo block, and then I'm going to do it in Push, and I'm going to do it in PowerShell. And that way we can kind of see how it reacts in both. So you can see in, make this larger. Is that visible for everyone? Is that kind of clear? All right. So PowerShell 6.20 has no output, but PowerShell 5.1 gets that nice object. So just kind of demonstrating there that it's gone. Sorry. So what do we do about that? We have some ideas. There is some open debate about how to actually implement it, but one of the ideas is that we create a convert from HTML command that you can use more generally and be able to take in a file and do it instead of doing invoke WebRequests to a file URL, be able to like specify a file, or just have text that's in a string or a stream or anything like that. So that's one way that we might solve it. But for now, we don't have that kind of planned out. Clicky, not worky, awesome. So HTTPS and certificate validation is now different too. So in 6+, we no longer support the service point manager. So if you've ever done kind of the advanced stuff in PowerShell 5.1, which I'll show in the following demo here, to kind of set some settings on service point manager to change the behavior of the web request, if you try to do that on PowerShell Core, you're going to find it completely useless because it's not even related to anything we're doing. So, and that included doing like custom certificate validation. And the ability to kind of trust everything. So what has been added is skip certificate check. So in PowerShell Core, starting with 6.0, instead of having to go through some convoluted process with Service Point Manager, you can just pass in a parameter, skip certificate check. And now you can access your unsafe internal dev-only APIs that you're definitely not having in production. So in 5 and older, you had to use the certificate validation callback on the Service Point Manager. And the other thing is that pain point when when GitHub, for example, changed to using TLS 1.2, how many people's scripts broke that they were doing anything with the web commands to pull stuff down? Yeah, there's a couple here, right? On 5.1, we don't support 1.2 out of the box because that's kind of a .NET thing. It has a little less to do with PowerShell and more to do with full effects, just not supporting that out of the box. And you have to enable it, and I created a module to kind of make that easier. I've already called Better TLS, but in 6.0, that is definitely not a problem you have to worry about. So we support 1.2 out of the box, we support 1.0 out of the box, 1.1 out of the box. Then, yeah, so the downside, though, of this change is that there currently is no custom validation for certificates in PowerShell Core. So if you were doing anything like, I have a list of trusted CAs, and I want to make sure only these ones, or I'm using a self-signed certificate that has a specific SHA, and I only want to touch this SHA, you can't do that in PowerShell Core right now. I've tried some kind of hacks to try to make it work, and we're just not there yet, so I don't have a full-fledged solution for that. So let's kind of show what I'm talking about here. What's next demo? Awesome. So this is what you had to do kind of in PowerShell 5.1, or still do in PowerShell 5.1, to kind of trust certificates. And I have to do this inside the demos here when I'm using 5.1 against our HTTPS endpoint because it's using a self-signed certificate. So it's the only way this would work. So there's a couple of things going on here. You have to add this ugly .NET type, return true. There's some guides out there that say, hey, just pass a script block with true in it to this certificate callback, validation callback. That's not going to work in all versions of full effects, believe it or not. So if you're trying to like make sure that you've got full coverage, this is really the only method that is like surefire. There's some cleaner code ways to do it, but basically what you're doing is you're creating a class and creating a method on that class to actually return true whenever a certificate is being validated, and then you have to pass in that as a kind of callback to that. So that's really ugly. But when you run that in 6, then you're going to see that that just does nothing. So hooray for backwards compatibility and forwards compatibility, right? So if you're doing this in scripts, the lesson learned here is that, so this, just to show you, in 6, we blew up. We got a nice error message that the remote certificate is invalid. But on 5, we get the actual stuff because that service point manager is actually being affected by that change. So now you got a version gate. So if you're doing some like cross-version 5.1, 6.0 stuff, you're going to have to kind of version gate and say, okay, well, if I'm on 5.1 and I need to trust all certificates, do this. And if I'm on 6.0 and I need to trust all certificates, you'll do what's in our next demo. So yeah, we added skip certificate check, so we're just going to do that. Now look how much easier this code is, way less painful, I think. I hope everyone thinks that's less painful. Well, we're going to run this and you'll see how it blows up on 5.1 and is totally fine on 6.0. So yeah, it's not a valid parameter. So there are going to be things that if you're trying to program back and forth between the two versions and make modules that work against them, you're going to run into some pain points, and this is one of them. I don't know that there's a lot of modules that are doing certificate skipping, but if you are, then this is definitely something. And in-house, if you're doing something for like testing, and you're going to have like, you don't know whether your test is going to run on PowerShell or PowerShell 6, or you're trying to future-proof your test so that when you can move to PowerShell 6 or 7, then it's going to run there. So this is something that you'll have to keep in mind. And then there's one more there, and that's the TLS 1.2 supports. So we have 2 different blocks here. We have the 6 demo block that we're going to run on PowerShell 6, and it's just calling skip certificate check, and it's called against this 8084 endpoint, and that 8084 is TLS 1.2 only. It does not support 1.0 or 1.1. And in the 5 block, we still have to trust the certificate that comes back as a self-sign. We have no way to actually say, okay, I just want to go have 1.2 like by default. No, you have to like do this piece of code right here. So if you're like wanting to do something to enable TLS 1.2 and you don't use better TLS module for that, this here would be your script block that you have to do. I recommend doing this way. I see a lot of blogs out there saying, oh, just set security protocol equal to TLS 1.2. Well, what happens if you're going against multiple endpoints and you have something that hasn't been upgraded to 1.2, still on 1.1? Now you've broken that where it was working fine before. So this BOR that's on here will basically say, hey, take what I already support in security protocol and add onto it TLS 1.2. It's kind of a weird thing for PowerShell. It makes a lot more sense in the C# world, what's going on there. But we'll go ahead and run this and just kind of demonstrate that they both work the same. But just the level of effort in those code bases, I mean, to make this work in 5, you have to do all this, and then to make this work in 6, it's like, oh, just skip the certificate check. So a lot of the underlying changes here, and I've already kind of briefly touched on this, is because in the move from 5.1 to 6.0, underneath the belt, underneath the hood there, we changed from WebRequests to HTTP clients. So these are .NET APIs inside of .NET Core and full .NET that are kind of like what the web commandlets are actually using to make their calls to the endpoints. And when .NET Core was originally released, it did not ship with the WebRequests API in it. It was added shortly after we were already committed to using the HTTP client, which was the only API in at the time. So work was done. I was not involved in that explicit work, so don't give me credit for it. But it was switched to the system.net.htp client. And from a PowerShell user perspective, that is mostly something you don't care about until you do. There's just some subtle changes, and I've kind of like covered some of these so far, like the fact that the service point manager, if you were using that for any of the advanced features, and there's a ton in there that you could have been doing, some like proxy tricks and things like that, that you might have been taking advantage of, they're gone. The not being able to access the file URLs and that FTP URLs, those are gone. So subtle differences, but for the most part, how you actually engage with the web commandlets has not changed. So like, you're still doing URI and still kind of getting back similar kinds of objects. But one of the reasons for doing this also is that HTTP client is a better .NET API for actually doing web requests. I mean, it's specifically for HTTP calls. And that's what the primary use case is, I believe, of the web commandlets. So it's a better fit for us. It gets better performance. It's faster. It is a little bit easier to work with on the C# side, which makes my work easier. And it's a little less clunky. The WebRequest API was added, I think, in like .NET 2. Don't quote me on that. But so it's kind of older, and that was before we really knew what we were doing with REST APIs in the world. So now everything runs on REST. It's like, oh, well, we should definitely have an API in .NET that's more focused towards just HTTP and not all the weird stuff that WebRequest also supported. So invoke WebRequest response differences is one of those changes. So the header values are now arrays. So when you did like invoke WebRequest and you got back the object and it had the headers property on it, that would usually be a single string on that. Now it's an array of strings, and it might only have one string in there, But that's kind of a difference that might trip you up a little bit. 5 and older, also the base response property was an HTTP web response, whereas 6 and up, that is a base that is an HTTP response message. So those are the .NET types that web request versus HTTP client return. So we give you back that base response, but if you were doing anything like inspecting error messages or looking at the base response property on like what you get back from invoke web request, then some of your stuff is going to break because things are all over the place. They're indifferent. They're completely different APIs. The properties are different, how you engage with them, what methods are available, how you convert the body to a string, all that kind of stuff are just completely different. So if you're doing any kind of more .NET related things on that return object, there's going to be some breaking. Invoke REST method now supports response headers, so that's one thing that we added to this. Basically you pass in a variable name, it sets a variable in your calling scope, and it populates it with the headers that are normally what you would get back with invoke web request. So a lot of APIs definitely require you to inspect headers for things like, is my OAuth token about to expire? Have I exceeded my API call limits? Lots of headers are really important that you need to get. But invoke REST method in 5.1 did not support the ability to get those. So what you'd have to do is you'd have to go back to using invoke web request, make your call, parse the body yourself, and look at the headers. That's kind of painful. So now it's possible to actually get the headers and the response parsed by invoke REST method a lot simpler. So let's kind of show that. Because it's a little weird way to engage with it. So let's see, this is, yeah, we're going to run it on both just to kind of show some differences between the headers here. So basically, I'm going to show that the types are different on the headers, just kind of show that one is a string, one is a array of strings. We're going to access that with the index of 0 to try to get the first one and see what that gives us, see what weird thing that does. And then we're also going to do select first and get the first one off of it so that we can kind of see how that reacts. And then I'll also kind of demo the response headers and how that works and show that it blows up on PowerShell 5.1, but it works on 6. But this is how you kind of engage what I was just talking about. You do response headers variable here. You give it a string, and then that creates a headers variable that then you can access and get the headers out of. So we'll run all of this here. That's a good error message. So we've got the 6.20 response there. You can see that the type of the headers is now a string array. Index 0 is going to be test value, and selecting the first one is going to be test value, because that's basically the response header that we've got. And then you can see here that on 6.0, it's actually going to give you that headers output. On 5, we see that it's a system string, and if you're doing index 0, you get T. Does anyone know why when you do index 0 on this, you get T? Yeah, so you get, it blows it up into a char array and returns the first char in that, which happens to be T. So don't try to make your scripts backwards compatible by using the index operator on that. Use select first, because you can see that it's consistent on that. And then you can just see that the response headers variable is not supported on 5.1. So again, some version gating to do some different things if you need to. Error handling. So another thing that's changed between these two commandlets versions, rather, between 5 and 6. So the errors are kind of weird on this. Has anyone done kind of any advanced error handling on invoke web request by like doing a try catch block on it? Show of hands. Yeah. So it's a pretty common thing, right? Like we need to know why our calls to the APIs failed so that we can provide meaningful information back. And this presents a problem because the objects are different that you're dealing with between 5.1 and 6. That means that your error handling is going to be a bit painful, and you're going to have to version gate for how you actually do that. The exception response is just like the base response, so that's what gets returned from the .NET API. And again, we're using HTTP client now instead of WebRequests, so they return different types, which means things are completely different. There's no access to the raw response in 6+. So right now, there's several open issues where it's like, I'm going out to this API, I'm getting error, but I need to parse the body. But you are stripping HTML out of it, and I can't read this. Or it's actually an XML response, and you're stripping all the XML out of it. I can't read this. So right now, there's no way to actually get that raw response. So working through that one, I've got some ideas how to fix it, but it's currently not available. So I don't know what to tell you on that one right now. And then another change is that now in 6.0, any call to anything that returns not a 200 level response. So like, 201 is success response. 200's like continue or whatever. These are all like successful response messages that HTTP has defined. And now they come back as errors if they're not in that level. So one of the things that I see as common practice in 5.1 was that you would make an invoke web request call against something that you know that's going to redirect, tell it that a maximum redirection of 1, and then inspect the headers to see what it's redirecting to. Pretty common practice, completely broken in 6. And the reason why is that that should be an error. That should never have been something that you were doing. You're telling the commandlet, I only want to redirect once, and the response from the other end is like, I'm going to redirect. That's an error. So that was corrected, but that means that some of those scripts that were trying to see what you redirected to are now broken. So I think I can solve both of these problems for some of the raw output and the non-200 level thing by making it available to just accept any response as a successful response and don't try to do any kind of our error handling, let you handle your own errors. So we'll go into the error handling demo to kind of show what's going on there, the differences. And just to be clear, I'm not going to cover all the differences between 5 and 6, and this is not completely about the differences. I do have a blog post that covers more in depth all these differences that if you want to see them kind of more up close and understand them more in depth, that would be a better place. But I'm going to cover a couple more, and then we'll move on to some other interesting things. So the demo block here is we're going to do basically an HTML response is what we're going to do. I have an endpoint on that web listener that will basically spit back what we send at it. So I'm basically just going to send it some HTML to spit back and have it do a 400 response code. So you can just kind of see this is going to be server operations. We don't care about that. What we care about is down in here. We're going to try to invoke REST method against that URL. We're going to do error action stop. We're going to try catch against it. And then we're going to check the error details and the response. And we're going to do some things here. First of all, we're going to get the type name of the response. We're going to get the server property of the headers property, see what that looks like. We're going to get the index of server off the header properties and see what that looks like. And then we're going to try what was a common thing in 5.1, which is to convert the stream to a string and output it, or in 6.0 now to actually just spit out the message. So this will kind of show the differences between the two versions and how they are just going to make your error handling painful, unfortunately. So helps if I select all and then do Troy. That's an interesting alert. All right. So in 6.2, we have systemnet HTTP response message. And that server property on the headers gives back this actual object. It's got product and comment, and we can see that it's Kestrel. Okay, that's weird. We're going to index that, and we don't get anything back, so there's no index on that. That's weird. And the raw response we get back is from error details. You see bad request and bad request. So all the HTML has been stripped out of it, and this is what you see on your screen, basically. On 5.1 then, Kestrel, you see, is there. That server property has nothing, but we get it out of the index on it. So that's going to be a difference in how you interact with that. The different type is up there. You can see that the raw response, we can actually get that full HTML response back from the server in 5.1. So we'll fix that soon. It's definitely a known issue and something that is important to get done so that your lives can be a little bit easier. So any questions on that so far? Comments? No? Okay. So authentication. One of the reasons why I got involved with the web cmdlets myself and programming on them was that the authentication for using them was kind of painful. We had this credential parameter on Windows PowerShell that seemed to do nothing like you wanted it to. Like you passed in a credential, but it still didn't do basic authentication. What is it doing? So that's kind of a pain point. And also, OAuth has become kind of like almost the de facto way of doing authentication to a lot of APIs. So doing the OAuth headers for that was, kind of painful and boilerplate code that needed to be pretty much everywhere if you were going to work on this. So I wanted to make this a little bit easier for myself and hopefully for everyone else. So I added the authentication parameter to this. It accepts a couple of different things. By default, it's none, which means that I'm not going to do anything special with the authentication. Basic, if you pass in basic, then you have to use the credential parameter, and you pass in a PS credential object, and that'll turn the username and password into a basic authentication header. And the other option is OAuth, and that will require the token parameter, which takes in a secure string, and that will have your OAuth token in it. Just a little side note on the credentials parameter. In 5.1, the credentials parameter actually does support basic authentication, but it only works in a challenge response situation. So the server has to return a 403 basic authentication required, and then the web cmdlets would go out and be like, okay, cool, here's my basic authentication header. There's been a change in the past, 5 years or so, where a lot of endpoints want explicit authentication for basic. They're not going to give you a challenge response. If you don't hit the endpoint with credentials, it assumes that you're doing an unauthenticated call and gives you different data. So like some APIs will give you some basic data for a user for pretty much anyone hitting it. But if you're the actual user hitting it, you get more details like when was my last login, what was my last login IP. And in that situation, you wouldn't want the API to return 403. You would want it to return some data that's useful to an anonymous user. So yeah, that's what the new credentials parameter does, but it only does it when you supply authentication basic. But you can still just, like you did in 5.1, supply the credentials and continue to do the old behavior if you wish. The other thing is that we no longer allow authentication over HTTP by default. You have to bypass this. And that should have been done from the start to kind of keep you from sending your credentials accidentally over HTTP. Because sometimes you're getting a URL from a user or some other entity that you don't know, so you don't even know that if it's HTTP or HTTPS. You're just passing it into your commandlet to go out and grab this, and you're sending on credentials along, and you could have been accidentally sending those over HTTP the whole time, and that could have been really bad. So kind of protect you from that, we've made that disabled by default, but you can do this really long parameter, allow unencrypted authentication, to bypass that behavior if you still need that. So we've got a little demo of doing that here. So I've got a admin here, and I've got a password that looks like all asterisks for me. I don't know about you guys. So I'm turning it into basically a PS credential, and I'm going to pass it in as a credential to this, and I'm going to say authentication based on. I'm using splatting here. Who here doesn't know about splatting? Nobody? Good. I like this room. So I'm just going to splat these parameters here. I'm going to pass in the URI, authentication basic, and then the credential, and I'm going to show you what it does in PowerShell 6. So I'm not going to show this on PowerShell 5.1 because it's not supported. And I'm also going to show you what happens to this when we do it over HTTP endpoint. So if you look at this, there's no HTTPS on this. We're going to just raw HTTP. We're going to see it blow up, and we're going to see how we bypass it then by appending allow unencrypted authentication. So we get this lovely error message, and I purposely made this painful and long and scary. So hopefully this dissuades you from sending your credentials over HTTP, but it does tell you how to bypass it if you want to. And when you do pass it in, you can see that you can get to the same HTTP endpoint without being hassled about sending your credentials over the plain air. Cookies and sessions. So kind of enough about the differences between 5.1 and 6.0. Like I said, if you want to see more in depth on that, I've got a blog that covers like I think 99.9% of all of those differences between 5.1 and 6, and goes way in depth. And I've done some previous talks specifically on that were longer than this one on just the differences between 5.1 and 6. So if you want to find some recordings out there, I think there's a couple of those available, and they're linked from my blog as well. So on to something a little different. So this is a feature that I don't see being used quite often enough. How many people have actually used session variable and web session before? That's a few hands, but not enough. I get asked this question a lot too. Like, I want to be able to persist things between calls to the web cmdlets. I want to be able to work with the cookies that are available. Like, how do I do that? And the secret is actually this session variable and web session, and these are kind of a weird thing to interact with. Like the response header example I showed before on invoke REST method, you supply into session variable a string, and it creates a variable in the calling scope, and then you can interact with that variable to do various things, such as add more headers or add cookies or change your authentication preferences. So I just don't see this being used a whole lot. Like if I look at a lot of GitHub projects that use the web cmdlets, and I see them kind of implementing them themselves, and it's like, well, this is something that's actually built into the web cmdlet. So I want to make sure that everyone's kind of aware of it, understands how to use it, maybe show you something that you haven't seen before. So we'll show a little demo of this then, so that it makes a little more sense on what to do. Oh, I missed the OAuth example. Let me show that real quick. All right, so just taking a step back on the authentication one, we do authentication OAuth and pass in the secure token, and that is a very unique token for this supercalifragilisticexpialidocious. Okay, good. So we're going to create a secure string for that. We're going to pass it in as a token, and we're going to do the same thing over HTTP, HTTPS, but you'll be able to see that it gets echoed back to us as the right header type. So yeah, you see the error when it's over HTTP, and then when you bypass it, you get this. But more importantly here is this authentication bearer, so it's passing in that for you. So back to the sessions one. This is a fun one, right? All right, so we're going to go against this get endpoint, which basically just echoes back a lot of details about our request. We use this one a lot in our tests to kind of like ensure that data that we're sending from the web cmdlets to endpoints is consistent, like what our default encryption content type is and all that kind of stuff. Making sure that when you set the content type, it gets sent. Those kinds of things. So we're going to make some calls against that endpoint. The response from invoke REST method, we're going to create this session variable there. So like I said, you pass in a string to session variable, and then it will create a session variable here. So you can see up here, I'm kind of setting it to null just to demonstrate that it doesn't exist before the call, and then after the call, it'll have some stuff in there. And we'll go ahead and display the headers first to show what was returned back. And then in the session variable, we're going to just kind of show what's in it. Then we're going to add a header to it. So we're going to add the X test header with the value of foo. We're also going to add a new cookie. So we're going to send an X test cookie with the value of bar. And we're going to look at what's inside the headers, what's inside the cookie. And then we're going to kind of call that back. So the way that you interact with cookies on this is it's using a cookie container object, and that cookie container object requires you to know the URI of the actual endpoint that you're going to have the cookie against. You can't just like get all the cookies, and you can't just set a cookie for every single URI. You have to kind of use a URI for both. And it does have to be like a full URI. If you try to pass in a string to this, it'll blow up. So this is one of those few times where like stringification in PowerShell isn't working, and you have to explicitly make it a URI object when you pass it in. But yeah, that's how you kind of interact with cookies on this. So I've had lots of questions like, I need to add cookies, and I need them persist between calls. How do I do it? This is exactly how you do it right here. Just create a cookie. There's a lot of options for this. If you look at system.net cookie on the .NET documentation, it kind of gives you like all the different things that you can do with that and kind of how you set it, the different things. But then once you've created that cookie, you add it into the cookie collection, so your cookie jar, and then it gets sent to the endpoint whenever you make the call. And then this is also how you retrieve cookies out of there. And like I said, you can only get the cookies for the URL that you know. And some cookies may be tied to like a top-level domain. Some cookies may be tied to a specific subdirectory of the URL. So it's going to change based on what URI you're doing and what the server set and all that kind of stuff. So that's why it's kind of weird to work with there. But enough jibber jabber on that. Let's go ahead and run this bad boy and show what it does. All right. So kind of just showing what we've got here. The headers that came back, so this is the headers that we sent to it, basically. This is the server responding back to us with what request headers we sent to it. So we sent it host with that. We sent it a user agent of that. So kind of the default headers, nothing special was sent. So this is what is inside that session variable that gets created. There's a headers section. There's some cookies here. There's use default credentials. So if you're on Windows and you want to continue doing that, and like, oh, I want to make sure that's using default credentials every time, and I don't want to pass this switch every single time, you can do that there. The credentials can be set there, so that's the -credentials parameter, so those could be persisted. Now you notice that token and authentication type are missing. I just realized that prepping for this presentation, so there'll be a pull request to fix that. Certificates, so if you're doing certificates, client certificate authentication, you can add the certificates in the certificate container there. and persist that between your calls. The user agent, so you could change that as well. So a lot of these things are just the same parameters you have on the web commandlets. And instead of setting those every single time or using a splat, you can use the web session variable to kind of take care of a lot of those defaults for you. Same with the maximum retry, proxy, and all that kind of stuff. So then this is the call that, this was the header that we added in there. We're just kind of like showing the header that we added, the xtest header inside of this is before we're sending the new request. And then this is the cookie that we created in there. It's just showing that I've got xtest cookie with a value of bar. It actually is glued to the get path of the URI. And then here's the request that we sent. So just going back up here into this. So we passed in that session variable that we've updated, add the cookies to, added the headers to. We passed it into that web session. And the result then is we get back the header that we added, the xtest header, and we've got back this cookie that we set. So that's how you use those two parameters that I'm seeing not being used en masse. So that's kind of a fun thing to play with, save you some time instead of having to splat all the time. So maybe check that out, and I'll work on getting some of the newer features added back into the session variable. And if anybody else wants to contribute to that too, you're welcome to. That would actually be kind of an easy thing to do. It's kind of a low-hanging fruit. All right, so who's bored out of their minds yet? Yeah. So web commandlets, there's so much going on with them, right? It's I joke that hour 45 minutes is not enough time for me to actually go into all the stuff that I want. I could talk about this all day. So the next thing that I want to kind of talk about is the internals and how it actually works under the hood. I've talked a little bit about it, like the HTTP client that is being used there. But basically, like, there's two main APIs that we call on .NET. And when I'm talking about APIs, I'm not talking about REST APIs. I'm talking about .NET methods and classes. So APIs have been kind of mashed into what REST is. And I just want to make sure it's clear that mostly when I'm talking about APIs here, I'm talking about .NET classes and methods. So basically, we're using the HTTP client handler APIs. The client handler basically allows you to set some settings on HTTP client and manage how it handles responses and all that kind of stuff. So HTTP client's a pretty extensible method. You could create your own HTTP client to do different things, HTTP client handler to do different things, to extend the capabilities of HTTP client. We're using the default HTTP client handler. We're not creating a custom one that does anything really awesome. But we do use it to set some things for it. And the kind of way that this is structured then, the web commandlets are actually 3 classes in PowerShell. So in C# underneath that, there's 3 classes that kind of build the web commandlets for you. There's a WebRequest PS commandlet base class. So this is what the kind of most of the functionality of the request is done. And then the post-processing is done in either the invoke REST method command class, which is what runs invoke REST method, or it's done in the invoke WebRequests command class. But the majority of the work's actually being done in the base class. So kind of a visualization of what this looks like is you have PS commandlet. So if you were in Thomas Rayner's wonderful session yesterday about building commandlets in C#, we derive the base WebRequests PS commandlet from PS commandlet, and then invoke REST method command derives from invoke WebRequests PS commandlet, and then invoke REST method is what's being called to that command when you actually run it inside PowerShell or inside your scripts. And then same with the invoke WebRequest side. So that's kind of what the inheritance model looks like there. So let's talk about web request PS commandlets and go back first. All right. So web request PS commandlet is the base commandlet. It is responsible for checking for success of the. One second here. Somehow it's skipped ahead several slides. Sorry about that. All right. So the main piece of this is process record, and if you saw Thomas's presentation, you kind of understand that that's kind of the process block of this web command, of this commandlet, of this base class for this commandlet. And kind of the order of operations of how this works is that first validates parameters. So the parameter sets on invoke REST method, invoke web request are pretty complex. If you've ever done like get help on these, you see there's like only 3 parameter sets or 4 on it, and you're like, okay, well, how is that working? There's like a bunch of things that break when I try to do different parameters to get. So we do a lot of runtime checks on the parameters to make sure that they make sense, that they're sane, and that means that we can't use parameter sets. And there's reason for that. So we have some like mutually exclusive parameters that you can't use at the same time. For example, you can't use authentication with a value of token and pass the credential parameter. That doesn't work. So like we have to check that runtime, and so that's one of the first things it does is just make sure that works. We prepare the session. So that session variable that I showed you, we're always creating that in the background anyways. So if you're not passing it in, we're creating a fresh one and populating it, and we use that to actually make the calls at the end. We process the authentication settings. So if you've got like token in there, we create the authentication headers for that. If you got the basic in there, we create the basic authorization header in there. Then we create the HTTP request message. So this is the class that HTTP client uses to actually send to the remote endpoint and get data back. So you create a request message that kind of has like your body in it, your headers, and that kind of stuff. We set the body contents on that. So there's a large section of the code dedicated to setting the body. So there's several ways you can set a body on the web commandlets, right? Like you can pass in a hash table, and it'll process it as a set of like key value pairs for form stuff. You can pass in a raw string. You can pass in a couple of different objects that it processes. Those are all documented in there, but we've got a pretty extensive piece of code responsible for just looking to see what you've passed us for the body and figuring out the right way to process that into the request message. So the next thing it does is it does the request, and it checks for success. So was this a successful request to the endpoint? Was it a 200 response or not, basically? It creates the errors if it wasn't, and then it passes off to the process response on the derived command. So this is still in the base command of web request PS commandlet, and it's done most of the work of actually calling to the endpoint, setting your requests, setting your headers, all that stuff. And once it's done all that work, then it's like, okay, well, invoke web request, you go do your thing, or invoke REST method, you go do your thing. And then the other thing that it does is it actually does the retry and follow. So another feature that was added was the ability to retry on endpoints. That is actually handled in the base class and not in the actual invoke REST method command or invoke web request. So kind of what this looks like as kind of a code graph. You can see like it goes out there, it's calling like validate parameters, prepare a session, process authentication, get HTTP client. So this is like the calls that are being made, the different methods being made inside of the commandlets, and what that looks like. And then we get to the end here, and it passes off to process response to the actual derived commandlets. So inside the code then, this is the PowerShell project. Luckily, there's been several sessions where this code has not been shied away from. So underneath the source folder, there is let me expand this out to commands utility. So the web cmdlets are inside of this commands utility module. Under commands and then utility, and then this web cmdlet folder. So this is where all of our stuff lives for the web cmdlets. And you've got stuff like JSON object and convert from and to JSON. But inside this common folder, we have the WebRequests PS cmdlet common CS. And that's where this class lives. And this is what it looks like. It's a monstrous beast of code. It's got, it's got, almost 2,000 lines of code in it. But it's basically doing everything that I just said there. You've got all the parameters defined. So most of the common parameters between invoke WebRequest and invoke REST method are also defined on this base class. So for example, the response headers that you can get back from invoke REST method now, that's actually defined on here as a private variable, but the parameter itself lives on the invoke REST method cmdlet because it's only specific to the invoke REST method cmdlet. It's not on invoke WebRequest. But we still have to define it here because it gets used in the base cmdlet, so there's actually a private value for that in here. But just scrolling through this, I'm not going to go through every line of code here, but this is kind of what we're looking at underneath the hood for a lot of this. It's quite a bit of code. It looks kind of intimidating at first. But believe it or not, it's kind of easy to follow. It's just long. It's not extremely complex code. We're not like, I don't know, doing like in-depth encryption or decryption or weird math or anything. A lot of it's like just setting string values on things. So it's kind of approachable. It's just long. It's gonna, if you want to get involved with it, this is where the bulk of the work is going to be done, is inside this class, and it just takes some time to read through. That's really all there is to it. But that's where it's at. So we'll move on to the next cmdlet then. So invoke WebRequest then. It derives from that base class. So kind of what it's doing then after the base class has gone and got the response for us is it comes back and it says, hey, is this a text response? Because if it is, I'm going to do some basic HTML parsing, and then I'm going to view a basic HTML response object. But if it's not, like if it's a text or binary, image or a binary or something like that, it returns a web response object that basically has the stream available in it that you can do with whatever. And then if you've passed in out file, I'm going to go ahead and write that to the file that you've specified. So it's not doing much. The bulk of the work is actually in the base cmdlet. So kind of what the internals of what this looks like is that it process record from the WebRequest PS cmdlet gets called. So once that's done, it passes off to process response on the invoke WebRequest command class. And then it goes out and calls stream helper. That's basically helping us get the response out of that to do some different things based on what response type it was, content type it was. It tries to do some, like, is this UTF-8? So it does some kind of analysis on what kind of data it is. Then it creates this web response content memory stream, and then it uses that stream basically to get the response object and save the stream to file. So kind of what this looks like in a map then is that it's basically just calling all these various methods here inside. So it's doing invoke WebRequest PS cmdlet, passes off to the process response, gets the stream helper, checks to see if it's string, and if it's not, do it this way. If it's not, if it is, do the basic HTML response. So that's kind of what's going on there underneath the hood. And where this is located at then here we have the core CLR, because that's easy to remember. Invoke WebRequest command core CLR is where this one's at. So originally there was some work done to make the web commandlets available in both the traditional fashion on Windows PowerShell and PowerShell Core. And when they decided to go, PowerShell 6 was going to be full .NET Core and not use .NET Framework. This became kind of irrelevant, and the structure hasn't been fixed. So technically, these could all live in one folder, and they're all actually core CLR. They're not specific to any kind of framework other than .NET Core. And we've already removed all of the .NET framework specific code out of it. But this is the file for it, and it's much shorter. Like, look at that. That's 60 lines of code for invoke or request. There's some other things, so like get response stream is actually in another file, and you could follow that and look through it, but it's not even impressive code either. It's kind of short. All of these are like I said, the bulk of the work's being done in the base commandlet. So invoke REST method then. What it's doing is kind of interesting. Who knew that invoke REST method could actually process RSS and Atom feeds? Anybody? Show of hands. Yeah, so like kind of like a, it's documented, it's on that, but no one uses it for that that I've seen regularly. I've seen people like go out and try to do things with that. But yeah, if you point it at an RSS feed, it'll actually spit that back to you in some meaningful XML format. And give you like the XML object that you can actually query with, like methods and all that kind of stuff. So that happens first. It tries to do that first. And then it's like, okay, well, is it JSON? Let me try to parse it as JSON. If that fails, it's like, okay, let me try to parse it as XML. Does that work? No? Okay, then let me just give you the string. So that's kind of the order of operations there. It's really simple. It's very much like try, fail, try, fail. Okay, give it a string or an error. And then write it to the file if you want to as well. So what the internals of that kind of look like is that it does the process record from the base commandlet, and then it calls off to the process response. So it's very similar to what happens in the invoke WebRequest command. Then it tries to process feed stream. Does anybody know what that does? That's the Atom RSS, right? That's kind of easy to see. Then it goes off and it gets the string stream and tries to process it. It checks the return type to see, oh, did they say that the content of this is application JSON? Maybe that's application. Maybe that's JSON. Maybe I should do that. Then it tries to get the encoding that's on it. So was this UTF-8? Was this one of the 4 million other Asian encodings that are possible on this? So it kind of checks that and tries to figure out what the string is encoded as. It decodes the string. And then it's like, okay, well, let me try to convert it to JSON. And then that failed. Let me try to convert it to XML. And then ultimately gives back a string. And that's what this looks like. So the bulk of this work is like, okay, well, let me just try to convert it one way. That fails, convert it another way. And the order of operations of that is Atom RSS, JSON, XML, string, error. So that's kind of what that code map looks like there. And we'll kind of look at that code here then. So this is the code for this. You can see that it is not a very long file. It's a little bit longer than invoke WebRequest is, but again, I'm just kind of blowing through this. There's not a whole lot to see. Most of the parameters are defined on the base class, but there are a couple of here that are kind of defined on here as well. Like this is what I was talking about, response headers variable. That's actually defined on invoke REST method and not on the base class. But yeah, it's trying to process the stream. It's not really hard. It's basically like, oh, Can I do this as JSON? Can I do this as XML? If I get any errors on this, then let me just assume that I can't and try the next thing. So that's where it's trying to convert from JSON. And this is how we're kind of like interconnected between the actual invoke web request and invoke REST method and the JSON commandlets. They have a dependency on them. So if we ever wanted to pull the web commandlets out of the PowerShell and put them in a separate module, we'd have to pull the JSON commandlets with us because we do depend on it to actually do our work. But that's that. Again, open source, take a look on that. So kind of what does that look like in a much easier to consume thing? I just showed you a ton of code. I showed you some code maps. Like, okay, well, that's not really easy for me to get my head around what you're actually doing there. What does that look like for real? Like, what's something bite-sized I can chew on this? So I've kind of created this under the hood. And again, this will be available on my GitHub afterwards. But this will show you a way more approachable thing of what we're actually doing. So basically, this would be a very simple console app that takes in a URI and makes a web call using HTTP client. And I just wanted to demonstrate what we're doing kind of simpler. So in 34 lines of code, without all that fun processing we're doing behind the scenes and all that extra work that we're doing to make it a little bit easier for you and providing all these parameters, the bulk of the work is being done in this little kind of chunk of code. It takes a URI. We're creating a HTTP client handler. We pass in that handler when we create the HTTP client. And we set auto redirect to true by default, unless you've told us not to. And then we create an HTTP request message with get or whatever method you've told us to with the URI. We might add some headers if you've done that in there, but I didn't do anything in this one. It's just to go to URI. So this is very much what under the hood it would look like if you just like invoke WebRequest URI, right? So that's what I'm doing here. Very simple. What's actually running under the hood, and we actually do get awaiter, get results. So these don't run asynchronously. They run synchronously because PowerShell commands run synchronously. So we can't really leverage that. Maybe we could. Maybe there's some ways that we could make this as jobs and think about that as something for the future. But for right now, we run it synchronously and get the result back. And then we convert the response to a string, and then we spit that out. So I'm not going to run this app, but all it would do is basically take a URI and gives you the string response back from whatever endpoints you gave it. And that's what's really happening under the hood. It's not a whole lot of magic. Most of the work that we're doing in there is just making it easier for you as a PowerShell user to engage with this kind of complex .NET API in a very flexible way. So web scraping. I get asked this question a lot. So how do I scrape websites for data? First of all, you shouldn't. I worked at LinkedIn, and web scraping is something that we're very much against. But a lot of companies are. They want you to use their APIs. That's why they created them. They've got endpoints for you to actually get data that you need out of it. If they don't have available from APIs, then maybe talk to the company about making what you need available from those APIs. Because that's where they'd like you to make your calls against. They don't want you going out and pulling their website in and scraping it for data. So, but what is web scraping, first of all? First of all, it's like, I've got an HTML page, and I need to get some data off of it. And I need to turn it into something useful, something that I can process, something I can look through and do that. Some websites don't care. They don't have an API. They don't have a terms of service that say, don't web scrape us. They're like, yeah, sure. Like, we're not going to create an API for that because like we've got two guys in a basement who just like write HTML code, and we don't even know what an API is. So maybe that's okay for them. So in that sense, yeah, that might be your only way of getting useful information off their website. But definitely, this could break your terms of service. It could result in bans. In some places, it might even be against the law. depending on what kind of agreements you have between you and the endpoint you're doing. So check it's OK before you're web scraping. But in the event that you want to do it, then I'm going to provide some guidance here. First of all, you really need to understand HTML and the document object model. It's really important to understand how HTML works. So if you're kind of just asking me, well, how do I get some data off a website? The first thing I'm going to say is go learn HTML. And unfortunately, that's what you have to do in order to do it. There's no easy way of saying, like, on this thing on this page, I want this text, right? There's nothing that you can tell that to and do that. You have to understand HTML. This might not work very well on JavaScript-heavy pages, especially with the web cmdlets, because we don't do anything that kind of will actually pull the rendered page from JavaScript. You've basically got the raw DOM that might be updated by the JavaScript that ran, might not. Just depends. Especially if there are things like when you hover over or something like that and the page changes, like that's not going to be there. We don't have a way to hover. So if you're looking for that, there's something like Selenium or whatever those other kind of test frameworks that you're doing that, you might be able to get more information out of that. It also requires some in-depth knowledge of the page content. So you can't just say like, well, I know one page, but I need it from another page. Now you need to understand how this page's document object model is structured in order to get anything off of it. And then it'll very likely break the next time their web devs push out the new change, which in some sites they're doing every minute. So, but I wanted to show how this, because I do get asked a lot about it, and I figured if I do it once, I can point to this later and say like, okay, I've done my due diligence. Everyone leave me alone. I really think that it's a bad idea. Go for APIs. That's my thing. And if you're trying to say like, well, their API doesn't support this, and I'm trying to just get around that, maybe you should take some reflection on what you're doing there and why. So what we're going to do is we're going to go out to Google, and we're going to do a query for how to web scrape with PowerShell, very meta. We're just going to start out with a very simple web request. So we're going to grab the URL. The document, and this has to be done, by the way, in 5.1, because like I said, parsed HTML is not a thing in 6.0. So if you're wanting to do web scraping, you're not going to be able to take advantage of newer features. So we're going to take that document from the parsed HTML piece. We're going to query this for the Q section. So I happen to know that the search box on Google has Q for the name of that box, so we're going to look for that so we can actually update our search query, which is how to web scrape with PowerShell. And then we're going to go through the forms and find the submit URL for that and generate that. We're going to append our query with it by basically taking all the inputs that are in that form with their default values, along with our updated search query that we've done, and create a proper GET request. So I also had to look and see how the GET request works for this. So that's another piece that you have to do kind of manually and understand how this endpoint that you're scraping works. I'm going to create the submit URL. So that's kind of taking that submit base and appending the query to it. And then I'm going to call again and get the search results. We're done, right? No, now we have to parse that result. And we have to get something meaningful out of it. So basically, I just want to get the result title and the link to that so that I could actually click and see the result that's there. So basically, we're going to look through this, and the results happen to be in an H3, so a header 3 HTML object that happens to have a class name of R. So basically, we have to search all the H3 elements inside the page, find the ones that have class name R, and then we have to loop through these and process them a little bit. So we're going to take the inner HTML, replace all their HTML goodies, so we just get the text. Then we also have to get the URL from that, which happens to have a href piece of that, so we can actually get that URL. And then we have to kind of decode all of that from HTML into actual readable strings. And then we spit this out. So what this is going to do is going to give us a list of titles and URLs. And we're going to format then in a list on that and just kind of show what happens. And there we go. So if you really want to know how to web scrape on PowerShell, I recommend you read these results. But you can see like there's something for business.com. There's a Reddit post. I'm sure that one's helpful. I'm sure I commented on that one. There's a YouTube. So you want to watch a video on how to web scrape. There's that. And then these are the URLs. You notice that the URLs are like kind of weird, but that's because Google like does their fake hover to show you like the actual URL that's going there. And then when you click on it, it does their whole, oh, well, this person actually clicked through on this. Now I can collect some data on that. So you can't really get the raw URL without doing a lot of JavaScript trickery, and that is way beyond what I wanted to do here. Maybe one of these guys explains it. So anyways, that's a very simple web scraping demo on kind of how that works. Any questions on the web scraping piece before I move on? I can neither confirm, no. No, yeah, so it's definitely against our terms of services for web scraping for sure. Like if you're web scraping LinkedIn, you're going to get blocked and possibly some lawyers at your door, depending on how nefariously you're doing things. Member data is very important. It's #1 to LinkedIn, and they actively check for those kinds of things and actively stop web scraping attacks all the time. Any other questions? Awesome. So I'm doing way better on time than I thought I would. So where are we going then? Like, what does the future of the web commandlets look like? What kind of plans do we have? So first of all, Swagger / OpenAPI, whichever one you call it, they're the same thing. If you're confused about that, they are the exact same thing. And JSON API are taking over the world. So these are not separate things. They're things you combine together. Swagger OpenAPI tells you like what the endpoints contract is. And JSON API is a standard on how you should respond. So what your JSON going in and out of APIs looks like. And these two are slowly swallowing up all of the ways that other people are doing it. A lot of things like Ember and .NET and Java support these kind of out of the box to kind of easily create APIs that you can work against any kind of endpoint and easily create usable objects native to your language. So these are going to be the future, and we'll need to invest heavily as a community in making the web commandlets work with these. What I think we may need to do is revisit invoke REST method and look at an invoke JSON method. I think JSON is going to be the de facto way. There's still XML out there, but the pressure from customers and just the general public is that stop giving me XML, I hate it. So I think that we'll have to invest even heavily in how we interact with JSON on the web. So there was some talk during one of the sessions on Monday about auto REST. So there's probably going to be a lot of that. I'm not sure if auto REST is actually creating invoke REST method calls underneath or just creating an HTTP client wrapper. But definitely that's going to be something that will kind of make your life easier. How many of you have written an API wrapper? Yeah. So like, it's a very common thing. I think that I've written a good 4,000 of these. Because everything's an API, so I need to access it, so I need to wrap it and create something. So this will definitely kind of help us. I don't know how it fits into the web commandlet story, maybe we have to make some changes. Maybe we don't use the web cmdlets in it, but that'll help. Separation from core. I've had several conversations with the PowerShell team about this over the years about we need to move the web cmdlets out. First of all, this whole difference between 5.1 and 6.0 is a pain. And some enterprising users have already started backporting all the changes into 5.1 as some kind of piece of their massive framework. So that's definitely something that needs to be looked at and considered. And another thing is that, in general, there was talk on Monday from Joey about actually decreasing the size of the PowerShell footprint. And that way you can have container things. I don't know if you've seen the install size, but I think it's over 100 megs. It's pretty large, and that makes containerization of PowerShell a problem. So you'd still be able to get it in as a module or package that gets added somehow, but we probably need to separate it. And what that means is that we still need to have something base inside the actual language to make it easy to download things, because how are you going to bootstrap the environment if you don't have anything to actually go and download the things you need that are extra? And this is not to say that we're gonna completely separate them. It'll be more like, well, the web cmdlets live on their own now, and when you install PowerShell normally, it's in there and available at probably a locked version of it. And then you can update it from the gallery, and that we can iterate on it separately. But if you want to install the small footprint version that you would install inside of a container, it probably wouldn't be included. You'd only have what I'm calling invoke download, but the name was definitely a point of contention in the RFC on this. So more time focused on the name, less time focused on the actual implementation. We are really bad at naming things, me especially. So improved language support and encoding. There's been several members of our Asian community who are constantly upset with the lack of support we have for working with Asian language sites. And I've been making lots of changes to try to accommodate that and allow for better availability. So accessibility and inclusion and all that kind of stuff are things that I want to focus on, I want to get working on, and would also be great if others from the community who have the same kind of spirit that we want to be inclusive like that come in and help with that effort to make sure that we can do that. We need to create tests for this, and my language skills are I speak English, so I don't have a lot of experience with some of these foreign languages, so it would be great if I get some people to help with some of the encoding and parsing problems that we have with those. More bugs. So we're going to fix bugs and we're going to create bugs. That's kind of the thing. There's quite a few bugs open on the repo, and there's more every day. And I'm the primary contributor for these. So I am looking for help, and hopefully this has helped make it less scary to kind of contribute on these, and that you can look through these slides and kind of get some guidance. And then you can find me on Twitter and ask me questions about this so that you can help in that effort of squashing all these bugs and creating more bugs as we go along. I tell you what, there's nothing more fun than breaking the PowerShell build. It gives me a sense of satisfaction. Convert from HTML, I talked about this briefly, right? We don't have a way to do parsed HTML. That's a problem. That's definitely a shortcoming. People want some kind of rich object, but I don't want the way that we did it before. There's some good .NET plugins out there, modules out there to kind of do this. Angle Sharp, I keep wanting to call it Angel Sharp, is a good example. And it can basically work with any angle-based language like XML, HTML, all that kind of stuff. And it creates objects then that we can search through and filter through and find data out of and all that kind of stuff. That needs to be done, but that has to go through an RFC process because there's no way that we want to do this as yeah, let's just get it out there, because the moment we put something out there like this, it'll be, consumed and broken and complained about how badly we did it. So we need a good RFC process on that one. We need to get that going, and there will definitely be some work on that. So any questions or comments or anything else you'd like me to add to what's in the future of PowerShell? All right. So thank you very much. Again, I'm going to put this up on my GitHub, but I created a short link for it. So bit.ly Web Cmdlet Prezo. That will get you to that. And that's kind of the full link at the bottom where it will be published at, and just some attribution credit for my avatar that everyone knows me by. So I thank you for your time, and I hope you enjoyed the Web Cmdlets deep dive.